Welcome to the talk on attentional focus effects on joint covariation in a reaching task by Charlie K. Howard and Nikita A. Kuznetsov, performed at LSU in the Neuromotor Control and Rehabilitation Lab. Focus of attention affects motor performance and learning. Specifically, external focus has been shown to benefit performance more than internal focus. These benefits can be explained by the constrained action hypothesis, which states that external focus encourages automaticity, whereas internal focus induces less efficient neuromuscular patterns. The primary focus of attention studies has been outcome measures and some descriptors of kinematics, but we also know that complex everyday movements have motor redundancy. The principal motor abundance states that the central nervous system does not use the same optimal solution to the task over and over. Instead, it creates functional linkages that covary to achieve the desired goal. Each attempt at task performance uses a slightly different solution, which allows flexibility of behavior. On the left, we have kinematic redundancy, where during a reach we have several different ways to achieve the end goal, while on the right we have kinetic redundancy, where we have a variety of muscular activations on a joint. From this, we have a guided question: does attentional focus instruction change how the redundancy is utilized by the central nervous system? A method used to analyze covariation of bodies' degrees of freedom in redundancy tasks is uncontrolled manifold analysis. For example, we can have multiple combinations from finger 1 and F2 to produce 10 newtons of force, where we can define a line of solutions deemed the solution manifold. Variance UCM, or variability along this line, does not lead to deterioration of performance because F1 and F2 compensate for each other's errors. If one is too high force, the other decreases. However, variability perpendicular to the solution manifold leads to performance deterioration. This is variability that is called performance relevant variability, variance orthogonal. Strength of covariation can be defined as the ratio between variance UCM and variance orthogonal. Greater variance UCM leads to stronger synergy. In our two-dimensional reachiness, we have three conditions. First condition is no focus, where the subjects were asked to complete the task as best as possible. The second condition was external focus, where they were asked to focus on hitting the target with the endpoint. The third was internal focus, where the subjects were asked to focus on extending their elbow. We had 20 young adults, all right-handed, who completed this task. Participants were asked to close their eyes while reaching the target by sliding the dowel across the table. Once the participant believed they hit the target, they would open their eyes to check their accuracy and then return to the home position. We had three hypotheses for this study. The first was external focus would lead to better performance than internal focus. The second, variance orthogonal under internal focus would be higher than variance orthogonal under external focus. And third, external focus may also decrease variance UCM, which would be indicative of exploiting a smaller range of successful task solutions to ensure kinematically consistent performance. Here we have mean response and standard deviations of reaching characteristics, where we only saw a main effective condition on movement time and not for average velocity peak, or peak velocity timing. Here we have endpoint accuracy measures, where the mean radial error measures accuracy, subject-centered radial error measures bias, and bivariable error measures variability. There was no significant effect of condition on performance measures. MRE, BV, and SRE were visually lower under external focus compared to internal focus. However, the effect was not statistically different, concluding that external focus did not increase endpoint accuracy in participants. We did have 3 participants who were strongly affected by conditions, specifically internal focus, where the MRE was mostly increased due to increase in bias. For variance UCM, there is no significant difference between conditions throughout any point. For variance orthogonal, internal focus was significantly greater than external focus for the first 50% of time. No significant difference was found in the last 50% of time. For delta V, no significant difference was found between conditions throughout the reach. We did not find the benefit of external focus or the decrement of internal focus on endpoint accuracy, maybe because the task was not complex enough. The task did not require explicit cognitive strategies. Other studies have also shown no focus of attention effect, and their reasoning was because the instructions were rather vague, so it was not clear what performance attended to. We are currently looking to the non-dominant hand for another study. Internal focus led to higher variance orthogonal in the first half of the reach. Early in the reach, participants with internal focus allowed more variability in their dowel trajectory. More broadly in our work, we would like to test the hypothesis that external focus / internal focus effect can be considered within an exploration-exploitation trade-off within reinforcement learning. The external focus may induce a strategy that achieves an end goal with higher accuracy, solution exploitation, while the internal focus, on the contrary, may encourage a motor strategy that explores a larger range of goal equivalent task solutions. Thank you for coming to our talk. These are my references.